For as long as humanity has existed, we've lived on a tiny world orbiting an ordinary star, sitting in a quiet corner of a very large universe. Yet somehow, astronomers believe they know how much normal matter the entire universe should contain. And there's a problem. For decades, nearly 40% of the universe's ordinary matter has been missing. Not dark matter, not dark energy, actual normal matter, the same kind of atoms that make stars, planets, oceans, and you. Galaxy clusters appear lighter than they should be. Galaxies themselves seem to have lost enormous amounts of gas. Even the vast regions between galaxies, the emptiest places in existence, are too empty. According to physics, that matter must exist somewhere. But every time we searched, we found nothing. Astronomers pointed the most powerful telescopes ever built into space. They mapped enormous sections of the sky. They used detectors sensitive enough to measure single photons. And still, the missing matter stayed invisible. Until now. For the first time, scientists may have discovered where the universe has been hiding its missing material. Not in some distant exotic object, but stretched across space in front of us the entire time. A gigantic filament of gas spanning tens of millions of light years, connecting galaxy clusters like threads in a cosmic web. And this discovery could confirm whether our understanding of the universe itself is correct. The matter budget of the universe. When astronomers count everything we can observe, stars, planets, nebulae, gas, dust, black holes, the number is enormous. But surprisingly, it accounts for only about 5% of the universe. The remaining 95% is made of unknown components, roughly 27% dark matter, about 68% dark energy. Dark matter has gravity but emits no light. Dark energy appears to push space itself apart, accelerating cosmic expansion. However, even inside that small 5% of normal matter, scientists noticed another mystery. About 40% of ordinary matter predicted after the Big Bang is missing. How do we know it should exist? Because the early universe left us evidence. The cosmic microwave background, faint radiation left over from shortly after the Big Bang, allows cosmologists to calculate extremely precisely how many atoms should exist today. The math is clear, but when we actually look at the universe, we only find around 60% of those atoms. The rest disappeared. The dark matter clue. Scientists didn't give up. Instead, they began asking a different question. What if the missing ordinary matter and dark matter are connected? In 1933, astronomer Fritz Zwicky studied galaxies in the Coma cluster and realized they were moving far too fast. Gravity from visible matter alone couldn't hold them together. Something unseen was adding extra gravity. He called it dark matter. In the 1970s, Vera Rubin observed spiral galaxies and found the same problem. Stars at the edges moved just as fast as stars near the center. Something invisible was holding galaxies intact. Dark matter could not be seen, but its gravitational pull shaped the cosmos. And that led scientists to an idea. Maybe ordinary matter wasn't missing. Maybe it was hiding where dark matter lives. The cosmic web. When astronomers mapped the large-scale structure of the universe, they discovered galaxies are not randomly scattered. Instead, they form a pattern, a vast network, a cosmic web. Imagine a three-dimensional spider web stretching across billions of light years. Galaxies sit along the strands like droplets of dew. Between them lie enormous voids, regions almost completely empty. According to simulations, they predicted something important. The filaments of this cosmic web should contain huge amounts of extremely thin, hot gas called the warm-hot intergalactic medium. And inside that gas should be the missing atoms. But there was a problem. The gas was so faint it was almost impossible to detect. Searching the invisible. Over the past 2 decades, astronomers slowly gathered hints. X-ray telescopes detected faint clouds between galaxies. Gravitational lensing revealed hidden structures bending light. Bright quasars illuminated enormous hydrogen filaments billions of light years away. These were clues, but not proof. We still hadn't directly observed the missing matter in the nearby universe until a recent breakthrough. The discovery. In 2025, an international research team analyzed X-ray observations of a massive region known as the Shapley supercluster. They carefully removed interference from black holes and other sources. What remained shocked them. A gigantic filament of extremely hot gas connecting multiple galaxy clusters. Length about 23 million light years. Temperature around 10 million degrees Celsius. Mass greater than several Milky Way galaxies combined. This wasn't theoretical anymore. They had finally detected the material predicted to exist since the Big Bang. The missing matter wasn't gone. It was stretched thin across intergalactic space, too diffuse to notice before. The universe hadn't lost its atoms. They were simply hiding in the skeleton holding the cosmos together. Why this matters? This discovery strongly supports the standard model of cosmology, known as Lambda CDM. It suggests the Big Bang predictions were correct. Galaxy formation models are accurate. Dark matter structures really exist. But one filament is not enough. To truly confirm the theory, astronomers must map the entire cosmic web. The future, Euclid mission. In 2023, the European Space Agency launched the Euclid Space Telescope. Its goal is ambitious: create a 3D map of the universe. By measuring galaxy shapes and positions, Euclid will trace dark matter using gravitational lensing and reveal where more filaments should be located. By the end of this decade, scientists may confirm whether our cosmological model is completely correct or fundamentally flawed. Final thought. For decades, astronomers believed a huge fraction of the universe's matter had vanished, but it never disappeared. It was always there, woven through space like invisible threads, forming the framework upon which galaxies, stars, and eventually life itself could exist. We weren't missing matter. We were missing the ability to see the universe's true structure. And now, for the first time in human history, we are finally beginning to see the cosmic skeleton of reality itself.